All right, so we're at limits. So a one-sided limit is where we're at, and a limit in general. So a limit. If you ask me what a limit is, I'm going to tell you a limit is a height. It is a height. It's a y value typically. Sometimes in a way, a series of y values. Sometimes, right? So sometimes it's defined and sometimes it's not. So this is a one-sided limit is the height. I like to use this word so much because it makes so much more sense and we don't confuse it with an x value. That a function approaches from either the left or the right side of a given curve or line, but literally of the function, right? A limit in general is the height. It is the height that a function that a function blank a given height we'll use the word that's easiest, hits. I like hits or bounds in a way. It's probably not an appropriate word, but it works. At a given height, if the left side limit is equal to the right side limit. So an example of this one-sided limit here would be to go from the left, you have a hole, but there's a break, and the function continues. If it's from the right, come from the right, there's a hole, and then the function continues, right? So if it's this one where it's equal, then we might have something like this, where it jumps over the hole, kind of hits this point, but it jumps over it. So I actually like limits. Limits are good. All right, so let's look at limits here. So let's look at limits. The limit, as we look at, if you look, x approaches -2 from the left. That's what that little negative means. It means left. And then we're going to look at the limit as x approaches -2 from the right. So two different things. So where is -2? This is -2, all right? So let's highlight how we're moving here. And I think this is fairly important because this clears up confusion. So from the left, I'm moving and I stop right there. I stop right there. And I'm at a height of 1. I'm at a height of 1. And I'm not gonna highlight it anymore because it's ugly. So at 1. So this y value, this height, is 1. So let's look at it coming from the right. So I'm coming from the right, which is this way, right? And stop right here. This height right there is -2. That height. And we have to keep that in mind because, you know, even at this stage, it still gets confusing. And I have a lot of math. And so don't you worry. You practice it, you get better, right? So how do I decide when I get to x equals -2? When I get right here at x, my pen is not working. How do I decide when I get to x equals -2? So x equals -2 between 1, the height of 1, and the height of -2. When there is a break, we cannot give it a limit. When there is a break, we cannot give it a limit. Now there's a defined portion there, but that we can't give it a limit. So what about, what's next here? We have x goes to 1, x goes to 0, and if you can't see, that's -3 from the left right there. X goes to -1 and -3. So let's go to 1 first. Here's 1, and it's clearly defined. This height is at -2. Oh, is that 1? Nope, it's not 1. My bad. My bad. Me and my mistakes. So x equals 1. Oh, I have. So this jump here is a little bit different from the jump that we had before. And my pen has stopped working for a second. And it's really my fault. So this jump is a little bit different than the one before. This is just a removable discontinuity. So it's not necessarily a jump. This is a complete jump. There's nothing in between here to here. But here, it keeps moving, and then it goes over. So removables, yes, the height is defined at 1. So make sure you note that the difference between that break, that jump in -2, and that removable at 1. So at 0, it's clearly defined. At -2, 3, at 3, it's clearly defined. At 5, the height is 5. If I look over to the left, it's at 5. At -1, my height, let's erase a little bit so we can clear that up. Better. At -1, my height is at, it's like 3, -3. All right. At -3, my height is at 0. And at f of -2, so this is different. This is defining. This is evaluating. So the only place that I can evaluate is if it's black. It's not. It can't be a hole with an empty space. So right here at -2, this height is 1. So let's see if that's the same thing at 1. At 1, this is 1. The height, it's got to be filled in, guys. It can't be the limit. Is going to be -2. So evaluate. 2 places where I evaluate. Now, continuous function facts. Formal definitions of continuous functions. We don't have to cover that. That's an AP Calc thing that we don't have to cover necessarily. But I would say this. F of x must be defined. We don't have to cover this, but if you want to copy it down, please do. F of x must be defined. I think it's helpful. The language looks confusing, but at the end of the day, when you go back to it, you'd be like, wow, this is amazing. Okay, so this just says the limit, as the limit of x approaches a from the left, some number of f of x, if it equals the limit as x approaches a from the right of f of x. So if this is defined, so basically the limit exists. Okay. Lastly, if f of x equals the limits as x approaches a of f of x. So basically, if the limit equals the defined values of f of x, it's not gonna hurt you to look at that. All right. So now we have this big old graph, and this is our practice. We might cover some of this in class. You're actually gonna do all of this in class, but I'll actually go through it right now since I have the opportunity to do so. So let's see if I can somehow make this work. Okay, it says describe what y values of the functions are approaching, and what this tells you about the continuity or the end behavior of the function. So the height or heights. So in my some of these heights mean infinite, right? So it says as x goes towards negative infinity. So as x goes this way, what's happening to this function? So this function looks like it's approaching, either it's going up to positive infinity or it's approaching this horizontal asymptote. This horizontal height of y equals negative 3. So I'm going to say it approaches negative 3. That's what it looks like. All right, as x approaches negative 2. As x approaches negative 2, right? What do we have here? So we have a lot going on. So I know, so we can't, it does not exist is the appropriate thing to say. It does not exist. However, we're going to make some notations here. Let me see if I can get my pen to work. Does not exist because there is a break. Put a little parentheses, break. However, as x approaches negative 2 from the left, f of x approaches, let's go look. From the left, f of x approaches negative 5. From the right, f of x approaches a height of 0. So we're going to write that out. From the right, and I just want to make that distinction for you because it might come up, right? It says as x approaches 1, f of x approaches, and it's defined 0. As f of x goes to infinity, as f of x goes this way, my y values go to negative infinity. So I'm going to write that. My y values, this height, goes towards negative infinity. As x goes to negative 4, my y values go to negative infinity. Technically, it doesn't exist. It says as x goes to 0. As x goes to 0. It's got a height of 3. And as x goes to 5, it's going to negative infinity. It's the same as this one. Let's see what else we got going on here. It says describe the end behavior of the graph of any function that has a horizontal asymptote. So it approaches the horizontal asymptote. So let's describe this graphically. So here's my x and y axis, and this is my function. And if you look, it's approaching x equals 0. Y equals 0. All right. Similarly, with the vertical asymptote, looks like this. Here's my x-axis. Here's my y-axis. Here's a curve. Right? And just some curve, and it's approaching whatever this x value is right here. So we'll say it's negative 2. So it's approaching x equals negative 2. So graphically, these are graphically proper ways of looking at this. Why is the function discontinuous at 2? So this is 2 because there is a jump discontinuity. in behavior, polynomial functions, they always go to either f of x approaches either infinity or negative infinity. We also say positive or negative infinity. That's a shorthand way of doing that without the R. State whether the graph at the right has infinite discontinuity, jump discontinuity, or point discontinuity, or is continuous. It has an infinite, and it's at x equals -1, and this is infinite discontinuity. Right here, we want to be mindful, do this work right here. I'll get you started. So as we approach from the right at -1, and we're going to hit a height of 1. So make sure you number these 1, 2, 3, and keep it simple. So which of the statements about the function are true? This is true. The height is 1 from the right. So these are true or false questions. I think that's it for today. So next class will be piecewise functions. Have a good day, guys.